Welcome everyone to my presentation on the hidden gems of Kubernetes and the lesser known features that you should be using. I am Saranya Nambiar, and I'm currently a master's student at the University of Leicester, and I'm also working as a product marketer at Taikun. Today, I'll share in 10 minutes some valuable Kubernetes features that often go unnoticed, but can significantly improve your deployments. So a brief introduction about me. I am currently, as I said, a master's student, and I have a diverse background as a software engineer and a product marketer. I also have a bit of speaker experience. Getting right into it. Kubernetes has become the de facto standard for container orchestration. Despite its popularity, many teams, they only scratch the surface of its capabilities. And so today I'm going to focus on 3 specific features that I consider are the hidden gems, which I have tried applying to my AI project. So this is just a case study that involves around a platform that combines multiple AI services where users are asked a set of questions. It uses Gemini for story generation and for illustrations. It is just my dissertation project for now, and the topic also emerged as part of it during conceptualization. So the architecture, I know it looks a bit big, but so the flow begins with when the user requests the story creation process through their browser. It connects to the ingress controller. And the ingress controller then forwards this request to the front-end service, which then initiates the whole story creation process. The front-end service communicates with the story service, which is responsible for managing the core story creation workflow. So when the story service receives the request, it initiates the story generation process and coordinates with the other services. The AI service is the one that plays a central role in this architecture. It provides both the text and the image generation capabilities, and it receives the request from the story service for story content and then communicates with the specialized AI APIs for the image generation. I've also employed a message broker to manage the asynchronous communication between the services, which separates the queues for notification, confirmation, AI tasks, and the image tasks. So when generating the content, the story service requests story context from the AI service, which returns the content that forms the basis of the user story. Then it moves forward to the image service, which interacts with the image generation API for creating a visual content to accompany the stories with the capabilities like to scale horizontally as the demand increases. So this, once all the content is ready, then the completed story with the images, if the user has chosen so, is sent back to the front-end service, which displays the final story with images to the user through their browser. Now, this project started as a monolithic architecture and then was made into a microservice architecture. So the hidden gem number 1 that I've used here is the network policy, which acts like a firewall inside a Kubernetes cluster. So by default, Kubernetes allows all the pods to communicate with each other, which is a security risk. So for my AI story generator, I had the intention that I wanted to protect the sensitive user data or the prompts. So I took into consideration that aspect, and I implemented network policies, which implements a zero trust model where communication is denied by default. This ensures services only communicate with components that they actually need to. And this slide, it shows how I have implemented the network policies in my application, restricting the AI service to only communicate with specific components. The second hidden gem that I've used is pod disruption budgets. So in cluster maintenance, it can disrupt the workloads. So pod disruption budgets, it tells Kubernetes, how many pods must remain available during voluntary disruptions. This ensures critical services maintain minimum availability during the upgrades or scaling events. And what are its benefits is it ensures that it is available like 99% uptime during cluster upgrades. And it also enables the AI services to run seamlessly when when maintenance is happening. And it is also essential for maintaining the user trust and for satisfaction of the users. Then the third hidden gem that I've taken into consideration is HPA. So standard HPAs, they scale based on the CPU and the memory, which isn't always ideal. However, for message processing applications like the AI story generator in question, the CPU or memory metrics, they aren't always the best indicators of the actual workload. So I have used RabbitMQ queue length as a custom metric for scaling. This, what it does, it allows for proactive scaling before users' experience slows down. So consider on a Friday evening, you're bored, you want something new to do. So there's a new app that has become popular. It enables people to write their own stories and then generate the images if they wish to. And you are curious as to what it does. Let me experiment with it. And we are humans. If one person is curious, there are 100 other people who are curious too. So everybody hits up. And suddenly, if I have not taken into consideration this aspect, the services start failing. So if I have implemented RabbitQ, then it enables my service to work seamlessly. So the queue length in RabbitQ, it directly represents my actual workload, the number of story generation requests that are waiting to be processed. By using this as a scaling metric, I can scale my processing pods based on the actual demand, rather than reactively based on the resource consumption. And these are the realistic goals that I targeted when implementing the features. And the key takeaways that I can mention is that each of these hidden gems, they address specific challenges in the modern cloud-native applications. The implementation can be incremental, but starting with the most critical needs. The benefits, they extend beyond the technical metrics to directly impact user experience. So thank you for your attention, and these are the handles where you can connect with me. I can show the demo of the application that I've developed later on when people connect with me, like individually. Thank you.
Awesome. Thank you.